Alright, so I'm going to be explaining how to solve the soccer goal problem from Expert TA. So it says, suppose a soccer player boots the ball from a distance of 27.5 meters into the goal. Find the initial speed of the ball if it just passes over the goal 2.4 meters above the ground, given the initial direction to be 40 degrees above the horizontal. So first, before we develop our strategy for solving it, I'm going to identify what we do and do not know. So we're given how far the ball travels in the X direction, and we're also given how far the ball travels on the y-axis. Lastly, we're given the angle that the ball leaves his foot from. We're looking to find the initial. So now I'm going to use what was given to set up a picture. So these are the two pictures I made using the information that was given to us. This picture shows the change in location of the ball with the angle that it's moving at. So the ball starts here, travels at 40 degrees, comes back down towards the goal, passes just over the goal. It's important to remember that the ball at its end point that we're looking for, it's still 2.4 meters up on the y-axis. This second picture I made is going to help us with the trigonometry involved in finding v, which is what we're looking for, relative to the angle and also to the horizontal and vertical velocities. I've included the trigonometry relating the given angle to the horizontal and also the vertical velocity, so we can use those to help us find initial velocity. Before we can use an equation to solve for velocity, we need something that we can plug in for t, and we aren't given a value, so we can find one. So we're going to relate t to the horizontal velocity. We know by definition horizontal velocity is the change in position on the x-axis over change in time. So we can rearrange that to get what change in time is equivalent to. And then we can plug in for these two things because we were given them. So we know that the change in position on the x-axis is 27.5 meters. And then we also know from the trigonometry that the horizontal velocity is the same thing as velocity times cosine of 40. And so this is what we are going to use for t. The next step is to fill in what we know into this equation so we can solve for velocity. So for y, we know that the ball is at 2.4 meters above the ground at its endpoint. We know it starts on the ground. We aren't told the initial velocity of the y-axis as a value, but we do have an equation for that. We know that it is equivalent to velocity times the sine of our angle. For t, we can just plug in what we solved for. For acceleration, we know it's going to be equivalent to gravity. The ball's moving up and gravity is coming down, so that's why I put the negative sign on the acceleration value. And then finally, we can just plug in again for t squared what we solved for t in the first part. So we have our equation, and notice the only variable in this equation is the one that we're looking to solve for. So now the only thing left to do is rearrange it so we can more easily solve for v. We can start by ignoring this 0. Next, I simplified this into this because the v's cancel out because one's on the top, one's on the bottom. Also, sine over cosine is the same as tangent, and then we're just left with the 27.5. Next, I simply multiplied through to get this negative 4.9, and I left this part alone for now. So I did this math to get this value, and I left this part alone. So this is what we are left with for now. To continue simplifying, I simply subtracted the 23.075 from both sides, and that leaves us with this. The next step in simplifying is to divide both sides by the negative 4.9, and that leaves us with this. Now, in order to continue isolating the variable to solve for it, we have to take a square root of both sides. After taking the square root of both sides, we are left with this. This next step, I multiplied both sides by v, as well as divided both sides by 4.219, and this left us with a value for v that we can solve for. So when you solve, you get v is equal to 17.48 meters per second.